Thanks for joining me today for the the product launch of the new snow melt control from HBX. I'm Julian Forster. I'm in charge of sales and marketing. So I'll kind of take you through the presentation here of the new control. So obviously we have a new product launch. We're pretty excited about this one. So today we'll kind of discuss the new snow melt control. We'll review the optical snow sensor and go over a few kind of key installation points so you guys are kind of aware of what should be done and what shouldn't be done. And then we can have some Q&A at the end of this. So HBX came out with their first snow melt sensor back in 2008, snow melt sensor and snow melt control. And we had a lot of success along the way, but it was definitely that time to refresh, to upgrade the control. We had some bumps here and there with the snow melt system, so we kind of all put our heads together and tried to come up with a better solution of how we get better control. So we were all hard at work here at HBX, each doing our role, and this is a control. So this is the SNO-0550. So the control is new. We have some new features, some new benefits, but we've been able to hold that price. So we're priced very competitively in the marketplace with the new control and with our optical sensor. So the new 550 looks like the other new 550 controls, the CPU and the Eco 550. We have a new user interface. It's simple to navigate and set up. You have all of your system information right on the main screen. We switched the preset snow conditions from a percentage to 4 different settings. So now how you're going to set the control up for your snow sensitivity is very light, moderate, and heavy. We kind of got away from the percentage. I think that confused some people during installation at what the minimum percentage mean and what the maximum meant. So we tried to keep it a little bit more simplistic here. So also another big thing is it doesn't matter if you need less than 100 feet. So you can cut the cable now on the optical sensor, the SNO-0110. So if a contractor only needs 50 feet, he can cut it to 50 feet. If he needs 200 feet and he wants to cut that and extend 200 feet, that's totally fine also. But we can review that. We also have a new snowfall anticipation feature. We'll discuss that in just a little bit. And then we also have a resettable fusing, so you won't have to worry about finding a fuse and changing it for the snow control. The SNO-500 went through 2 changes. The first one didn't have a fuse, and the control could burn out if that optical sensor was cut. So what we did is we added a fuse that if the optical sensor is cut, it won't burn out the control. It was just burning out the fuse. So we tried to keep it a little bit easier on this one with the resettable fuse. So some of the features and the benefits, obviously the snow conditions, they're preset. It's pretty easy to set up. You can do an injection or mixing valve. You can control injection and the system pump. We do have a smart testing function on this control also. And then you can kind of see all of your system info. So it's easy to program. It's easy to set up. Contractors should like this a little bit better. It's just a little bit more intuitive in regards to the user interface. And then obviously you use our optical sensor that's been around since 2008 also. So this is the status screen on the control. So you can see the slab temp with the target. You see the supply and return temperatures. Your outdoor temperature. You can also use a wireless outdoor sensor for this that we have, the Wave 100. And then below the temperatures, you can see it'll show your boiler and your system pump if they're on or off. In this setup, we're doing a floating valve up, down. You can see if it's on or off. And then also, if you see it says snow none, so that's the live snow conditions that is happening outside. So if it's snowing very light, it'll say snow very light. If it's snowing moderate outside, it's going to show snow moderate. So that's another change. We see the live conditions so the homeowner can see kind of what's going on outside. And then we have a multicolored backlit display. So it's good for a contractor if he's comes into the room, the mechanical room, takes a look, he looks at the control, he kind of knows what's going on based on the color of the screen. A lot of the time when our tech support takes a phone call, he will ask what color is the display so he can get an idea right then and there what the control is doing. So with the wiring of the SNO-0550, the first connector is for your optical sensor, and then we have a demand output. This can be basically a switch or for a force melt demand, and then you have your boiler contact, and then your demand input is for supply return and your outdoor sensor. And next is the 120 volt power. And then the last three would be your relays, such as your system pump, injection pump, or floating valve up or down. So with the 3-button interface, it is different than the dial on the last control, and it is quite simple to navigate. This display is the same display that we use on our thermostats, our THM 100 and THM 200. So if you've used a thermostat before, you should be able to navigate your way through any of the 550 controls quite easily. So if you hit the enter button, that takes you to the setup menu. You can go to your snow rates, you press enter, and that gets you into the snow rate setup. So there's no more percentage as per the last control. We've simplified it to 4 different settings. So most people will have this set to very light. They don't want to see any snow. So that's the default. And then you can actually see the cloud on the left-hand side on the screen. That snow will kind of trickle down, so it's a bit of a kind of a moving snow, and then the snow will get anywhere from very light to heavy, and it's just more snow falling faster. So that's kind of your snow rate setup. Once again, very light is your default. So your design temperature, this is straight from the manual, so you can see basically how easy this is to set up. So the first one is just changing your delta T in your system, and then you have your minimum system temp, default to 50. Your maximum is set to 120. You have your warm weather shutdown at 40 degrees, and then your cold weather shutdown at 0 degrees. It says I'm having a problem. I just want to make sure you guys are still with me here. Can you guys hear me? Okay, I can hear you guys. Cool, thanks. So the next kind of setting is your slab setup. So your idle temperature, this is a minimum slab that you've set up in your system, so it's 20 degrees. So to turn an idle temperature off, what you do is you just set the temperatures below 39 degrees Fahrenheit or above 80 degrees Fahrenheit. Then you can see that you don't have any idle temperature running. So it'll physically say off. In our last control, we didn't have anything that said off. We always just said, okay, set it below 39, and you know you don't have any temperature running into your slab. So this physically says off. So you have your melt time. So this is a melt temperature. The melt time is after the snow falls below the setting. It will stop the system. Really, that time is if once your system turns off, it'll continue to run for, you can set it anywhere from 1 hour to 99 hours. The default is 3 hours. So that can melt any residual snow that's on your driveway. Or if you give it a force melt demand, so let's say you flip a switch that you've set up, your system will run for 3 hours. And then we have our sensor location. So you can set up the optical sensor remotely or right in the slab. So here's the screen you'll select for your mixing type. It's either injection or floating action. And injection is the default. And then the demand type. So there's 3 different demand types. There's a force melt demand, there's a standby / idle, and then the new one, which is anticipate. So a force melt demand, once a demand is given, the control initiates a force melt demand. It runs for the melt time that you've set up in the control. So for instance, the previous screen was set up for 3 hours. So when that time has elapsed, the control goes back into standby or idle. So standby, there's no heat to the slab. Idle, it means you're maintaining a set temperature in your slab. So in standby and idle, when the demand signal is given, the control turns on to initiate melt mode. And once again, standby, there's no heat. Idle means you're maintaining the slab temperature. So with anticipate, this is a new mode for the SNO-0550. So this is a really good setting if you're expecting snow in the next couple of days. You can set up the control, and if it snows, the system will go into the melt time. Goes into melt for the melt time. So we had it set for 3 hours. And the anticipate days, this is the number of days that the control will be on and anticipate for the demand. So once again, it's good. Let's say in the morning you're getting ready for work and you know it's supposed to snow this sometime today. It kind of puts that into an anticipate. So it kind of brings it out of an off to an on in a sense. So the next one is your testing. The first one just basically gives you your control information, a version number of your control. The function test sets your outdoor temperature at 10 degrees Fahrenheit and your system temp to 70 degrees. So it's basically simulating colder weather because most of the time these controls are commissioned and tested and installed during the warmer months. And then it'll go through all of your testing of each relay, and you'll be able to know if it's working or not. It'll say on or off, and then you'll also hear the relay click in the control. So So the wiring in this diagram is when you have your sensor remotely mounted. Oh no, this is just for injection mixing. So you'll see your system pump, and then you'll see your injection pump on the far right-hand side of your relays. And then your next one, this is the one with the remote sensor. So you'll see in the far left-hand side the SLAB sensor. So if you remotely place your optical sensor on a roof, in a flower bed, if somebody's forgot to put the installation socket in the driveway during the pour, that's when you can use it as a remote setup. So you're still using the optical sensor, but we need to sense that SLAB temperature. So then you would just install the added SLAB sensor, and this is where you'd put it in pins 4 and 5. And then this diagram is just showing you with a floating action valve. So on 1920 is you see the valve up, and on 2122 valve down, or valve up would be open, valve down is closed. So now we'll get into the snow melting system, and the biggest difference, what we've done that a lot of you guys know about, is the optical sensor. So what this allows you to do is see the actual snow that's falling outside. So it's not a typical continuity sensor where snow hits a sensor, the heater in that sensor melts the snow, and then it makes continuity between the brass fingers, and that sends a signal out to the system, the control, to turn on. With us, we can actually see the amount of snow is falling, and we can tune the snow melt system based on that rate. So if somebody sets it for very light and they don't want to see any snow, so the moment it starts to snow in a very light setting, that system will turn on. If after a couple of months that heating bill is quite expensive, as we hear about, they can kind of bump it up to a light. So it's not going to initially turn your system on right away. It's going to wait until it kind of gets beyond a threshold from very light into light. And we can talk about that. So there's two parts here. There's the installation socket, and basically what it has is a dummy sensor screwed in on the top. It comes with 100 feet of wire. It also comes with a very good 3-year warranty, and the sensor is made of a polycarbonate plastic, so it is really one of the hardest plastics you can get. So it doesn't matter if you drive over the sensor, it doesn't matter if it gets scratched up, beat up, gouged, it's not going to affect the optics of that sensor. So here's your snowfall intensity settings. So on a typical continuity sensor that's out there, the moment it starts to snow, your system will turn on. So with us, if you kind of follow that graph along and see that it's starting, it's snowing very light, and then it starts to snow a bit more. If you have your system set for light, the moment it goes from very light to light is when the HBX system turns on. So you're going to have a little bit of cost savings at the beginning, and then if you follow along with that graph, over 3 hours later, it basically drops from a light into very light. So at that point, your system will go into the melt time. So we had a default of 3 hours set in the control. Your system will run for 3 more hours to melt any residual snow melt on the driveway. If before that 3 hours is up, it goes from very light into light, well then your cycle starts again, and your system will continue to run. So it is a really good way to have some savings before and at the end. We're the only snow melt system that works this way, and price point, our system just can't be beat. So we'll quickly run through a little bit of the installation, some of the main points we see here at HBX and what we hear in regards to, what the key points people need to make sure they're kind of doing and following. So I guess first and foremost, this is what a contractor should do. He should read the manual. We definitely do have more calls on snow melt systems than any other control, any other application out there. So this is what happens when he doesn't read the manual. So what we do is we send a jolt of 50,000 watts through the control into the contractor, and he will never use these controls again. That is a joke. We tried to get that passed, but it didn't. So he's going to use those controls again. We'll just try to keep it simple for him. So obviously the big one for an installation error is when we first started putting these controls out there, was that people were cutting the cable. So if they only needed 50 feet, they were going to cut it at 50 feet. Well, that affected the ohm rating from the sensor to the control. So what we did is we tried to put more warnings on through the sensor itself. We put a sticker that said, "Do not cut the cable, it will void your warranty." We just made more warnings in the manual also of not cutting the cable. So now it doesn't really matter, which is really good. So if you need more than 100 feet, you can extend the cable up to 200, 250 feet. And you're just using a 2-pair shielded 18-gauge cable. So, and the contractor will want to waterproof that cable where they've lengthened it, just for some added insurance. So a couple of years ago, what we started to see were some common problems. Was there wasn't proper drainage for the snow sensor. So what needs to be done is you got to drill a hole through the bottom of the socket to allow any moisture, water builds up inside that socket. So there is a hole at the bottom of our installation socket, and you have to drain through whatever a contractor is placing it on. Sometimes they place that on styrofoam. It could be on stone. There's different things that the installers put it on, but there definitely needs to be proper drainage. If it's not done, the socket may fill up with water. It turns to ice. This ultimately can cause damage to the sensor. So we didn't get as many calls last year regarding this, but 2 years ago we definitely saw this as being a big issue. So installing the sensor at the correct location in the slab is critical for a properly functioning snow melting system. The sensor should be located where snowfall is normal. It's not affected by surrounding buildings or drifting snow. The sensor location should be halfway between the two heating pipes that are installed in the slab, so you get a correct temperature reading. So also you'll want to put, for ramp mounting, to make sure that location is at the bottom of the ramp, so the snow and the ice flows over top of the sensor from the top. So when mounting the socket and the cover plate in the snow melt slab, you can use the rebar mounted holes that are there to level the socket. You want to make sure that your socket is flush with the slab. Sometimes we'll see installations that the sensor is half an inch to an inch below that slab, and then water can pool. So we don't want that, just in case they don't seal that, and then water can kind of get in below and could short out that optical sensor. So proper height is of importance also when doing the snow melt. So on the socket there's 4 brass plugs, and these are used to make contact with the brass ring on the optical sensor to read the slab temperature. So we always say don't manipulate the plugs, as it will affect the proper function of the temperature sensor. So they're there for a reason. Contractors don't want to take those out. And then with our optical sensor, you can remote mount that sensor, like I said, on a roof, in a flower bed. We've heard people building boxes and placing it on the side of their house. But with that, you'll need to install the included thermistor into the slab you're melting, so we know the temperature of that slab for the system to function properly. So within the optical, the SNO-0110, we do include a 10-foot thermistor, and that 10-foot thermistor is coated in a rubber coating just for more weatherproofing, so just so that doesn't fail within your system. Also, if you're using paving stones, it's always kind of suggested that you have external slab sensor so you can read the temperature correctly. So this slide just shows you the cable from the snow sensor to the snow control. You want to run it through a conduit. Don't have your drainage for water down the same conduit. We have seen that. We were out visiting a contractor outside of Calgary one day, and he had issues with the snow melt system. Come to find out, he was putting his drainage down the conduit, and it shorted out his optical sensor. So that's something you don't want to do. And that's the presentation.